It is 2:47 a.m. and a premium enterprise customer named Marcus is staring at a blinking router. After 2 days of intermittent outages and a board presentation 5 hours away, he opens a support chat and types a single word: cancel. Before Marcus even closes the window, the system executes 7 coordinated actions. A priority technician is dispatched. A mobile hotspot is overnighted. His tier receives a temporary upgrade. Total elapsed time, 11 seconds. 0 humans involved. Building this level of restraint into the agent is the primary engineering objective. It ensures the system can resolve the crisis without burning a $500 autonomous credit on a $50 problem, or waking a manager who isn't needed. This structural diagram maps the exact position of this agent. We start right here, at Agent 01, the core autonomous decision-making loop, deployed directly into live customer service. This charts failure modes of unconstrained autonomy. Without safety layers, models generate hallucinated commitments or trigger financial leakage. To prevent this, the architecture uses hard-coded guardrails, evaluating tool-grounded policies and fixed financial caps per tier before any action is approved. A basic thermostat reacts. It sees one temperature and flips one switch. An autonomous agent decides. The ability to autonomously navigate these constraints while maintaining policy alignment is the product. The market for this autonomy is projected to exceed $45 billion by 2028, driving a rapid wave of industry consolidation. In June 2026, Salesforce acquired Intercom Fin for $3.6 billion. Their objective is to wire Fin's battle-tested Apex AI model directly into the native Service Cloud data model via the Atlas reasoning engine. Meanwhile, Sierra reached a valuation over $15 billion, serving 40% of the Fortune 50. Their core differentiator is Ghostwriter, a system that compiles plain English descriptions into executable agent policy. Decagon tripled its valuation to $4.5 billion by automating multi-step technical workflows through proprietary agent operating procedures, bypassing code altogether. And Zendesk pivoted to an API-first hub powered by Claude 4.2, switching to an outcome-based pricing model where enterprises pay only for verifiably resolved interactions. You have Salesforce and Zendesk acting as integrated platforms, while Sierra and Decagon specialize in premium enterprise execution and technical workflows. This diagram outlines the autonomous decision-making pipeline, a continuous loop of perceive, reason, safety gate, act, and learn. Starting at the far left, perception functions as a high-fidelity data fusion layer, aggregating state from across the organization. When Marcus types his message, the system evaluates the primary text vector. A fine-tuned Roberta model identifies intent, classifying intermittent service outage with a 0.94 confidence score. Simultaneously, the system executes a secondary vector, querying a graph database. This retrieves structured customer data. It pulls his lifetime value score, verifies active hardware warranties, and checks local grid outage states. Finally, dense passage retrieval acts as the third vector, pulling relevant unstructured knowledge articles into context. By aggregating verified system state with the full context assembled, the pipeline moves to the cognition phase. Here, the language model executes its chain of thought reasoning. To prevent hallucinated responses, the system places a strict constraint on the model's output. The generated action plan must conform entirely to a rigorous JSON schema, utilizing only a pre-validated list of tool IDs and parameter bounds. That constraint action is mathematically gated. Expected value equals lifetime value impact times resolution probability minus automation cost. For Marcus, LTV is $50,000, probability is 0.92, and cost is 3 cents. The action scores high, green light. Based on that approval, the model sequentially composes 7 specific tool calls, ordering everything from local grid checks to priority dispatch. The plan must first pass through the single most critical module of the entire architecture, the safety gate. Operating independently of the language model, it is a deterministic circuit breaker evaluating 3 parallel conditions. The first is the financial guard. The system calculates the total cost of the action plan and verifies that it does not exceed the hard-coded autonomous budget limits set per user tier. The second is the confidence guard. If any single composed action in the sequence has a model confidence below 0.85, the plan halts. The third is the Customer Impact Guard. The system analyzes the proposed actions against a policy engine. Any high blast radius changes, like an autonomous refund over $50, route directly to a human, regardless of how confident the model is. The execution flow here is strictly binary. If even a single guard trips, the entire loop immediately aborts and triggers an intelligent handoff, passing the full context summary to a human agent. Deploying this heavily gated architecture into live production environments produces immediate, measurable outcomes. This dashboard tracks field impact across the industry. We are seeing systems achieve 80% autonomous resolution, enabling $15 billion valuations for providers like Sierra. But despite those successes, there is a glaring paradox. 40% of agent projects are predicted to fail. Those failures happen because engineering teams successfully build the reasoning engine, but critically neglect to build the deterministic safety gate. The system also faces what engineers call escalation drift. Customers learn which phrases trigger a human handoff, forcing administrators to tune and recalibrate the safety thresholds weekly to avoid overwhelming their support queues. The underlying cause of these failures often traces back to the data pipeline. 62% of underperforming AI support projects fail due to insufficient data preparation, not because of limitations in the model's capabilities. The safety gate and the underlying data pipelines provide the architectural moat that a base model cannot offer on its own. Agent 01 flawlessly resolved the 3 a.m. server outage strictly because of its constrained perception and hard safety gates. But this current architecture operates with a critical limitation. It processes the immediate state perfectly, but possesses zero persistent recall of previous interactions. To intelligently manage long-term customer friction, an agent must be able to remember context across months, not just minutes. It is time to upgrade from reactive, isolated decision-making. Next in the series, we move to Agent 03, the memory-augmented agent.